Introduction to Data Structures in Python Programming Language. Introduction. Hi everyone, I hope you are all doing well. In today's tutorial, we will seek to explore the concept of data structures in the Python programming language. Data structures are also referred to as collections in Python. This is because they support the storing of several pieces of information. This builds on the concept of variables as we have learnt in a previous lesson and the power of iteration, that is, loops, as we have also learnt in a previous tutorial. This is not a difficult section to understand in Python programming language. As always, if you understand the logic behind these concepts, then you will have the best understanding. And if you have the best understanding of the use cases, then you will have no difficulty in implementation and deployment. Let's get straight into it. The limitations of variables. At this point, we have effectively learnt about the concept of a variable and its use cases. We know that a variable is a container that resides in RAM, which contains information that we may use at any point in our program, provided that the variable exists. However, a major limitation of your standard variables is that each variable can only hold a single piece of information. Looking at variables from a logical perspective, variables indeed make a programmer's tasks easier. However, there are certain situations when the use of variables will not be feasible. For example, what if we encounter a situation that requires us to keep a record of all students in a class? For example, what if we are required to store the names of 10 students in our program? In the world of programming, there is no incorrect solution. It's just a matter of finding the most convenient and efficient solution for both you and your CPU. One way we could go about solving this task would be to create 10 variables in our script and assign a student name to each. The above approach would look something similar to this. Looking at the solution on the previous slide, we see that we would obtain 100% for constructing a functional script. However, efficiency is something we need to take into consideration. If we were also required to print all student names to the console, we would be required to print 10 individual variables. This is possible but not feasible. It is exactly for situations like these that data structures come into play. The first data structure I would like to introduce you to is called an array. An array allows us to store multiple or several or more than one piece of information in a single variable. It will assign a collection of values to a single variable. Data structures in Python. You may think of a data structure as a variable that is mutated. That is, it has undergone some syntax changes which now enable it to store more than one piece of information. The array is the most well-known example of a data structure. Just as with standard variables, data structures, mutated variables, first need to be created before we attempt to utilize them. In Python programming language, the creation of an array is done as follows. Array name is equals to information pieces. Line number in Spider IDE. Name given to the array. Assignment operator, the equals to sign, will assign the array and its associated values on the right to the name given on the left. Information pieces being assigned to the data structure. All information pieces should be separated by a comma. Square brackets indicate to the compiler that an array is being created. As seen above and on the previous slide, our array in Python is a single structure denoted by square brackets, and all pieces of our information may be stored within this structure. So applying this logic to our example, the information we would like to store is student names, 10 names to be exact. These student names will be in the form of strings. So essentially, we will create our student array as follows. You can give the array any name you like and fill it with any information you like. So essentially, we will create our array by giving it a name and assigning it to square brackets. Thereafter, we wish to populate our array with 10 names of students. These 10 names of students will be in the form of strings. Each student name must be separated from each other by using a comma. The final result will look similar to this. Students is equals to Sarah, Jack, Florence, Jiren, Cauliflower, Goku, Kale, Hit, Kunchi, Shiv. Notice that we have inserted 10 pieces of information into an array data structure that is being stored in one variable. Run the script. Now, upon printing the names of the students, all we have to do is print the array itself. Print students. Now upon running the script, output will show as follows. And we are able to observe the same logic that applies to standard variables. Upon printing the variable name, we are calling on it and are returned with the contents of the data structure. A cool and interesting application of data structures arise when combined with a for loop. Remember, a for loop allows us to iterate over a sequence data structure by using a temporary iterator variable. Recall from our previous lesson. For iterator variable in sequence, statements to be executed. Using a for loop, we are able to iterate through each item in an array. Using our example, we would do this as follows. For student in students, print student. Take a moment to run your code and understand what we have done. Look at the syntax of the for loop one slide back. We have an array called students in which there are 10 items which are names of students. We have configured a for loop to iterate through each item in our sequence. The item being processed in each particular instance of the for loop will be stored in a temporary variable called student. Remember, you are allowed to name your temporary variable anything you like as long as you use that name throughout loop processing. And as we are able to see, output of the for loop syntax shows as follows in the IPython console. Notice that our for loop has printed each name in our array. This is because each time the for loop condition was encountered, the temporary iterator variable took on the next value in our array, which effectively got printed to our screen as output. This process continued until there were no items left to iterate over in our array. That is, we reached the end of items. To get a better understanding of arrays, you need to imagine an array being a row in a table. A standard array resembles a single row of a table. Putting it into perspective of our problem, we will have a one-row table in which there are 10 values, and each time our iterator variable moves in succession, we are passing the next value in line. Just as we get tables with more than one row, we get arrays with more than one dimension. A one-dimensional array is the same as having an array with a single row, just like in our example. A two-dimensional array will be the equivalent of having a table with one row and one column. I would like to take you a step further and introduce you to a new concept called indexing. You see, an array follows the logic of a table or spreadsheet. There are times when we will require all values to be read in succession, which may be done using a for loop, and there are times when we will require only a specific value from the array. The process of obtaining a specific value or specific values from an array is called indexing. Indexing arrays. Indexing an array in Python is done by specifying the name of the sequence you would like to return a value from, followed by the integer position of the element you are interested in. The integer position of the element you are interested in needs to be in square brackets. For example, if we would like to index Sarah from our array, We would proceed to do it as follows. Print students 0. You may be wondering why I passed in an index value of 0 for the first element in our array. This is because sequences in Python are 0 indexed. This means that the index value of the first element in a sequence is 0 and not 1. Output to the previous indexing syntax will show as follows. Sarah. And we will be returned with the first name from the array, which is Sarah. Always keep in mind that Python sequences are 0 indexed. It's not just a complete tutorial without a diagram. Below is a simple diagram to help you when indexing a Python array. Index number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Always start indexing with 0. Important note. I would like to mention that I will not be providing information on all functions that can be performed on these data structures in Python. I would first like to provide you with an overall idea of the use cases and syntax of these concepts in Python. I would like to make future videos that are short in duration which quickly cover the additional features that is offered in Python. My aim is to first ensure that you have an understanding of the concept and understand the logic working behind it. I would like to mention to you that arrays in Python are mutable data structures. This means that we are able to change and update the values of items within this data structure after we have created it. Within an array, we are able to insert, remove, and update a value within the sequence, therefore making it a mutable data structure. An array will allow for duplicate elements to exist. That is, more than one instance of the same element. A data structure that is very similar to an array are lists. Lists in Python. A list is another commonly used data structure in Python programming language. Lists are much more flexible and powerful when compared to arrays in Python. Using a list data structure, each element inside it may be of a different data type. Unlike arrays in which all elements need to be of the same data type as the first element, lists have the ability to be expanded or shortened dynamically in your Python program. Lists have one major downfall, and that is when it comes to arithmetic operations. We do not have the ability to perform arithmetic operations on an entire list, but we can do so with an array. Lists are declared in the same way as arrays, that is, using square brackets. Lists are mutable. Lists allow us to insert, remove, modify, order the contents of the data structure after creation of it. It is important to keep in mind that lists are 0 indexed. Lists will allow for duplicate elements to exist. This means that there may exist two or more of the same elements in the same list. The logic and reasoning behind using a list or array remains relatively similar. You see, giving programmers the power to use lists and arrays is the same as asking a shopper if they would like to write each of their 100 items down on separate A4 page and shop with that, or simply write all items on a single A4 page and use that. A simple example of a list in Python. Random list is equals to 5 true Python 10.0. Notice that not much has changed between an array and a list. The prominent way to distinguish between an array and a list is by viewing the contents to see if they are alike or not. If all items are of the same data type, then it is an array. If otherwise, a list. Another difference that will make itself visible to you when you work with lists and arrays is that lists offer much more computational power and are versatile in programming.